Again, we're on this n. There's an n here. Is there at least one n on this one?
Yes.
Yes. There's two n's here, as a matter of fact. Are there two n's here?
No.
No. So the most that I can take out, in fact, I could split that n into n times n and n, because that's my n squared. So I can take one out. Okay. And that is it. That is my greatest common factor. Now, what we're going to do, and you have to sit down and do something else, okay, is on this, what we're going to end up doing, this is your greatest common factor, and then today we're actually going to we're going to factor each, but I'm going to go ahead and factor this one. So once you pull out that greatest common factor, you're going to have, so if I took this and I multiplied it and I got this, what would be missing? In other words, if I took this times this, how can I get a 3 in front? What would I have to have here? I'd have to have a 3. So what's left is a 3. If I took out two m's, so my 8th graders really need to watch. If I took out two m's, how many m's are left? 1. So I'm going to put 1 m here. And then if I factored out 1 n, but I had 2. How many n's are left? 1. Okay. So what happens is that if I take this now times this, 1 times 3 is my 3, m2 times m1 is my m3, n times n is my n squared. So we're factoring out what's in common in both. So now we're at the second one. So now on this second one, we took out an m squared. Is there any? Oh, but wait a second. How can I get a 4? 1 times what will give me a 4? A 4. And then m squared times what will give me m squared? 1. So I really don't need to put down a 1. So that's the exact same thing. And the same thing here. So in fact, I can close that because if I take m squared n times 4, I get 4m squared n. So this is the factorization. The number in front is the greatest common factor. So let's look at the second one. So look at the 18 and the 21. So especially for my 8th graders, you need to get this down. Can you see a number that goes into both 18 and 21?
No.
A 3? Now let's double it. Is there a 6? 9 goes into this, but 9 doesn't go into this. So the biggest one is a 6. The biggest is a 6. Oh no, you're right. Excuse me. 6. Thank you for the correction. 6 does not go into this. Girls and boys.
Girls and boys.
Okay. Christian. All right. So the biggest number is a 3. So we're going to pull out a 3. And then look at your x's. What's the highest power of x that's in common in both of them? Is x to the 4th in common in both? No. Is x to the 3 in common in both?
Yes.
Yes, there is an x3 in here. In fact, there's one extra. So x3, 3 to the x3rd is our greatest common factor. And then we're going to see what's left to make the complete factorization. So what would I have to multiply 3x to the 3rd by to get 18x to the 4th? Yosemite. I'd have to multiply it by a 6 and what else? X to the 3rd times what will give me x to the 4th? Times an x. And then minus 3 times what will give me 21? 7. Okay, hold on a second. Sir, Joelle. All right, so on this one, an x to the 3rd, I've already got my x to the 3rd, so this is it. So always double check 3x to the 3rd times 6x is my 18x to the 4th, and then 3x to the 3rd times 7 is my negative 21x to the 3rd. And that is my complete factorization. The front number is the common one. Skip these 3.
Skip one.
These 3 here. Okay. All right, hold on a second. Okay, girls and boys, this is a big group. And I still have a class to teach? Yes, sir. Okay, so here we go. So on this one, okay, I'm just writing down some names and sending emails. I have no choice. All right, so on this one, we need to find the largest number that will go into both of these. So the only thing that I can think of doing is doing a factor tree. So I'm going to flip it over on the back and put 189 and 144. Well, I'm going to separate a little bit. 189. And by the way, this is 9 plus 8 is 17, 18. Who knows a number using your rules of divisibility that will go into this?
3.
Matthew. Yeah, bigger than 3? 9. Because it sums to 18, so I can break it up with a 9. And 9 goes into 18 2 times. 9 goes into that 9 1 time. So can this be broken up again?
Yes.
It can be broken up into 3 times 3, and then 7 times 3. And then we'll look at this one. I know for sure this breaks up into 12 times 12. And then we can break this one up into what? Or 4 times 3, either one, because in fact I'll do this one 6 times 2, and you'll see that it comes down to the same. 2, 3, 3, and this one is 2 times 3, 6. It should come down to the same. 12, 12. Well, I don't need the exponent yet. In the 6 times 2, it's the same thing. 3 times 4. Oh, this one here, nobody caught me. This one is, okay, girls and boys, if you can get out a book or something else, the people in the back that just came in, or you sit there quietly. All right, so again, on this one, what's in common then in this factor tree and in this one?
3.
So 1 3 here and another 3. Is there another 3 in common?
Yes.
Yes, so 3 and 3. Now is there a 7 in common in both?
No.
No. Is there another 3 in common?
No.
So the biggest number that's in common that I can pull out here is isn't it 9? Because the biggest one that was in common was 3 times 3, 3 times 3. So is this a 2-term? Yeah. So what's left is right here. On 189, 9 times 21 is 189. So what's left on that first term is, if I'm making my parentheses here, it's going to be 21, and then we'll, are there any x's in common?
No.
No. So I'm going to just put this x to the 9th, and then we already know that 9 goes into this. 9 times what? So if I do it the factor tree, I'm going to see what's left over. A 2 was left over, a 2, and another 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So 9 times 16 is 144. So again, this is going to be plus 16. So actually this I'm going to put a little bit closer. So 9 times this should be this term. Plus 9 times 16 is that. So this is the factorization of the binomial. So that's probably the hardest one there. So I'm going to go down to this one. Is who thinks they can see? Okay, hold on. Who thinks they can see the biggest number that will go into both of these is a 9. Get one out of the back seat. Is a 9. Yes, ma'am. All right. And then, hold on. Okay, hold on. Yes, sir. Okay, hold on just a second. Get out a book to read, but right now I need to be going over these. Joel, hurry up and have a seat, please.
I can't throw in my tissue?
Yes, you can.
Can I go to the nurse?
Hurry, you go.
I'm bleeding out.
Can I go?
Have a seat, Joel.
He's a buddy. Oh, yes.
Christian, I need you to settle down.
I can be your
No,
buddy.
no, no, you're in this class.
Can I go use the
Shoot,
restroom?
okay, have a seat, you're in
Can I
8th
go use
grade.
the restroom though? Sure.
Wait just a couple minutes.
Huh?
Just a couple minutes, Joel, and I'll let you go. All right, I need you to be respectful. I still have a class to teach. Again, so on this one, the 9 was in common. Is there an m to the 6 in common on both of these? Is this m to the 6? No. Who thinks they know the biggest m that I can pull out from both of these?
M6.
M to the 4th.
Yeah.
M to the 4th. Joelle, settle down. And then there's nothing left in common, so now we want to see what's left. 9 times what will give you 18m to the 4th?
2.
Times 2. So 9m to the 4th times 2 will give me that. Plus 9 times what will give me the 27?
3.
3. And this is m to the 4th times what m power will give me m to the 6th?
And 2.
M to the 2nd. Very good. And that's it. That's the factorization. The number in front was the greatest common factor. And then we're going to go down to the number 16. Okay, then on the 16, now it's going to be the greatest common factor, and then we're going to have a trinomial. Who knows the biggest factor of 25, 15, and 20?
5.
5 goes into all of those. So I know I can pull out a 5. And then I'm going to look at my the smallest x value that's in common in all. Is x to the 4th in common in all of them?
No.
No. Is x to the 3rd in common in all of them?
No.
No. Is x to the 2nd in common in all of them?
Yes.
Yes. So I can pull out an x to the 2nd, and that is it. So now we want to see what's left. 5x squared times what will give me 25x to the 4th?
5x squared.
5x squared. Very good. Right. Then plus 5x squared times what will give me 15x to the 3rd? 3 times what? 3x minus 5x squared times what will give me 20x squared? Minus 4. So that is the factorization. It says to factor each polynomial, and the greatest common factor is the front number. Okay. Anthony, are you getting this? Okay. All right. Then the next one. Anthony, help me with this one. What's the biggest number that will go into all of these?
4.
Is going to be 4.
6 could also go to all of those.
Okay.
Are you high?
Okay. Joelle, if you want to open the door, you can do that.
Huh?
If you want to open the door and put if you're warm, you can open the door and put the little kickstand on the door. All right. I need 2 of you in the back to go take a seat. That's too many back there. Okay. All right. On this one then, who knows the largest a to what exponent is in all of them? A to the 4th. And then times 4 times 4a to the 4th times what will give me 16a to the 4th? Is 4, just 4. Minus 4a to the 4th times what will give me 24? A to the 6th. Is 6 and then a to the what? How can I go from a to the 4th to a to the 6th?
A squared.
A squared. Plus 4a to the 4th times what will give me 12a to the 8th? You're right. 3a to the what?
4.
A to the 4th. Good job.
Can I go use the restroom now?
Yes, you're right. Okay, Joe, I'm sorry. Anthony, did you think it was something else? What did you think it was? Well, this is 4 times 4 is 16. 4 times 6 is 24. 4 times 3 is 12. And nothing, these have nothing else in common. So this was the biggest number, and those are correct. Okay. And then let's look at this one. I'm going to go to the largest factor that's in common. And I'm going to look at, in fact, is there anything? I'm going to look at the 15 because there's only one way to get 15, which is 3 times 5. There is a 3 in this one, but there's not a 5. There's a 5 in this one, but not a 3. So in fact, in this one, there's nothing in common except for 1. So no number will be pulled out. And then go to your, who thinks they know what X value can be pulled out? Okay, I can't have you making the noise back there. Put it away. Is very good, X to the 13th. So that is our greatest common factor. And what's left is 35. 35, who knows X to the what power? I'm going from X to the 13th to the 27th.
2. No.
It's not going to be 2.
15.
It's going to be 15. No, it's not 15.
It's 14.
14. All right, plus 24. I'm going from X to the 13th times what will give me X to the 19th? X to the 6th. Minus X to the 13th times what will give me negative 15 X to the 13th? Minus 15. Okay. Right. And let me see what time it is. Okay. All right. And okay, we're just going to do a couple more. We're going to go way back here. Okay. Okay, girls and boys. Okay, girls and boys. I've got.
We're supposed to go outside.
No, we're not supposed to. Okay, girls and boys. Hold on just one moment. Okay, hold on just a second. All right, I'm going to do this last one and then we'll call it a close. On this one, you cannot, the last one, you cannot have a negative in front, so you're going to pull out the negative. Okay. All right, and does anybody know where Charlie is? All right, so on this one is, who can tell me, again, so we can get ready to go, who can tell me what number goes into all the numbers? 11. Who can tell me the largest t value? T to the 4th. And then who knows the largest r value? A regular r. And then what's going to be left is, what's going to give us 33? Well, we've already got a negative. A 3 t to the what power? Just t, and then r to the what?
Just regular R.
It's squared.
It's squared, thank you. R squared. Minus 11 times 44 is going to be 4 t to the what? Oh, it's plus, okay, no, he's right. Negative times negative is a positive. This should be a positive.
Yeah, it should be a positive.
Joelle. Go ahead. So on this one, the t to the 4th, I've already got it. What's the r going to be? R to what power? R to the 1 plus negative times what gives you a, it's going to be a negative. And it's going to be a negative 2. A t, and is that it? Okay. All right. So put that in for 8th graders. Put that away. Save it for Monday.
No, actually don't. That emoji, I know.
Yes, go ahead.
That emoji, I know.
Okay, you can head on out. We're going out.
It's too easy, bro. Dead. Skull, crossbones, rope.
No, we're all
Let's go.
Police officer, white police officer. That's what Anthony's saying.
Who's that white police officer?
Anthony's saying that.
Yeah, come on, that's
Lost nobody can wait for. Oh, you don't have to go yourself. Let's go.
Look at
This is the very bottom of the list of the ugliest girls in the class.
I didn't even bring anything here. I should have.
Oh yeah, I know you saw that.
Wait, are we going to lunch?
I know you saw that booty.
What?
Wait, are you going to lunch?
Yeah.
It's lunch.
It's time for lunch.
I love being literally the second person you in.
Yeah, man. You. Hey. Oh.
Love the fact that I was rated second to last as the ugliest girl in the class.
So no one's waiting for me?
Third.
Literally no one's waiting for me now? Last week I ain't waiting for me?
You got. I'm waiting for him.
Haley, come on.
By the way, I'm about to let out a nasty one.
That's KJ stuff.
Oh my god.
Where's KJ?
Where is KJ?
KJ. I think KJ stuff.
Dang, that smells nasty.
What?
I smell that nasty one. We're gonna need some, what's it called? Some Clorox Ultra Stain Remover.
That is nasty.